Hi, everyone. Welcome to the afternoon session on update on machine and deep learning. And I'm so excited to be moderating this panel with three experts who I think are going to be talking about some kind of relatively new topics. Some of it was touched on previous panels, but I think we have some really different perspectives on this panel. So I'll kick things off by starting with just a quick level set on machine learning and deep learning. So obviously we're here today at the AI Med conference, and AI or artificial intelligence is often conflated with the term machine learning, but really they're not the same thing precisely. Instead, it's more precise to say that narrow AI systems, which are really focus-built artificial intelligence systems that are designed to solve one really specific task, are built with machine learning techniques. And within the world of machine learning, there are a variety of different what we call models. And one subset of those models are known as neural networks. This is a biologically inspired type of mathematical model, but it's very superficial inspiration derived from biology. So just think of it as a function. And within the set of neural networks, there are a subset of machine learning models that are known as deep learning models, or that are built with deep neural networks. So within the machine learning world, there is a separate concept of deep learning, and that's a subset of machine learning. And you've probably also heard about some of the learning techniques or learning algorithms that go into training these models. And the point I'd like to make is that there are different learning algorithms: supervised learning, unsupervised learning, reinforcement learning. And these are somewhat orthogonal concepts to the types of models that are that we can imagine and train. So you can use supervised learning or unsupervised learning or reinforcement learning techniques to train models that are deep learning models, or that are machine learning models that are not deep learning models. So these are somewhat orthogonal concepts. Most recently, a lot of the attention has fallen into the reinforcement learning realm. There are some pretty interesting results around reinforcement learning as applied to deep learning models. So that's deep reinforcement learning. And there are a lot of questions that researchers are still asking about machine learning from a computer science perspective. But at a really high level, machine learning is about pattern recognition. It's about training a model, which is, again, a mathematical function, to perform some kind of task that is difficult to describe programmatically. But instead, we derive a function, so often through giving the machine a huge number of samples, and the machine learns a function that can take, for example, an image and output a classification, a description of what is in the image. So the most popular type of learning algorithm that we're talking about a lot at this conference in particular is supervised learning, which is, again, this idea of teach by example, wherein there's a training phase during which a huge amount of training data, that is data that has been labeled by a human expert, is used to build a model or a function. And this is a particular kind of function that, for example, if we're doing object classification, takes as an input an image and outputs a classifier, such as cat or dog. And so there's a separate training phase that's really a data-intensive and compute-intensive phase of building the model. And then once the model has been built, it can be deployed or make classifications or predictions, typically in real time or in a short amount of time. So it's the learning phase of the training phase of the model that's really compute and data intensive. And I think that where we are today in 2018 at this AI Med meeting is we've now begun to internalize machine learning. We've started to think about the capabilities, the applications, the limitations of machine learning. And I think for me anyway, there's a question on the table, and often I get asked this questions by other folks, and that question is machine learning, and deep learning in particular, there's this deep reinforcement learning that has been really, has produced some really remarkable results. Is it fundamentally different than the incremental improvements that we're used to seeing coming from computer science and technology generally? There's a phenomenon in technology and in computer science, sometimes we talk about something called Moore's Law, in which we believe that there is an acceleration to the growth rate of the capabilities of technologies. And is it the case that machine learning represents merely an incremental improvement on existing technologies that are fueled by incrementally better algorithms coupled with better data, faster compute resources? Or is it fundamentally different? Does this represent a not just incremental or evolutionary improvement in technology? Is it a revolutionary new technology? Is this a stepwise function that is fueled by machine learning and deep learning in particular? And I think what's interesting about machine learning from my perspective is that there are some aspects that are wholly new to us, especially when we're talking about deep learning models. There are aspects of algorithmic bias. There are aspects of explainability. We worry about the robustness and generalizability of models. These are ideas and problems and challenges that we as a community of researchers have not had to face before. So if it's the case that to me somewhat indicates that we're dealing with something qualitatively different here. And if that's the case, that we're dealing with something fundamentally different, then what are the secondary and tertiary questions that we should be asking about how we design these systems, how we interact with these systems, how we build trust around these systems? And fundamentally, I think it comes down to the question of how humans engage with machine learning and deep learning. And with that, I'll pass it on to our first panelist, Layla.
Hi, everybody. Bear with me. I have a little cold. My name is Layla. I have a background in neuroscience, a couple decades of business experience with an MBA, and a master's in counseling and psychology. I keep a small clinical practice to stay immersed in the feeling space, and I'm truly honored to be here. I think it's very forward-thinking for AI Med to have the voice of emotional intelligence here in the conference. So my passion space is emotional intelligence, in particular in technology. How do you use feelings to get people to feel stuff, to get them to do stuff, to increase emotional engagement? So I'm going to start with a couple of really quick audio clips.
Alexa, I'm sad today.
Sorry to hear that. Talking to a friend, listening to music, or taking a walk may help. I hope you feel better soon.
Okay, number 2.
Alexa, my friend passed away today.
I'm not sure.
And number 3.
Alexa, today's the anniversary of my mother's passing.
I don't know that.
Oops. So how can we serve better, in particular as we aim to have technology and AI and machine learning and virtual personal assistants more immersed in our society? So imagine how many people have one of these, Echo or Alexa or Cortana or Siri or any of these in your homes, okay? So imagine if when you set up, let's say your Alexa, that you did a profile and it asked you for significant dates. And you said, March 1st is the anniversary of my father's passing. And then it asked you, well, what do you want me to do on that day? Do you want me to check on you? Should I remind you to send flowers to someone or call someone? If you are feeling sad, should I offer to do something? These are the ways that the technology exists for a lot of the voice recognition, a lot of the context recognition, facial movement, eye movement, and we can incorporate more human engagement into technology by adding a lot of those human elements. So what does the research say? Harvard professor says 95% of purchasing decisions are subconscious. I've heard 93, I've heard 97. A Harvard Business Review's research found that basically emotional engagement, connecting with people beyond customer satisfaction, went a lot farther for increasing engagement on a human level. So the gist of it is having the voice of human behavior. So we have tech people, we have executives, we have scientists, we may have physicians. If we're lucky, the research and the design will have the patients. But having the truly immersive, the psychology, the feeling space, the intangible, having a lot of that voice in the conversations of our design. So in engagement design, everything matters. The word choice, the images, the sounds, the feedback. In particular, again, if most of what you do is subconscious. So where's an example of an opportunity in EHRs? So how many physicians here would you say are frustrated with use of EHRs at any capacity? Okay. So EHR is the top factor contributing to stress in the medical field. So what's an example of a way that EQ could help with that? Well, what are the ways that EQ design, using the multisensory, using feelings, having a lot more of that could enhance the design of EHRs in order to be able to create greater engagement. And so in the future, EQ in AI will be a necessity and not a luxury. Thank you.
Hi, I'm Christina Chen. I am a nephrologist at Beth Israel, and I spend part of my time also doing research at MIT. And I just want to start by saying that thank you so much, Anthony, for organizing this, and for Freddie and Priya for putting up with all of us. Thank you. And I've just been so impressed by all the really smart, amazing people that I have met at this conference, and I feel really honored to be here. So today, I like to talk about what I think is really one of the cornerstones that makes AI in medicine successful. In order for these amazing AI tools to really realize their full potential, you have to have good data. So this was touched upon in the prior talk, but that is one of the missions of the lab that we're in. So we have the product Mimic, and this, as many of you probably know already, is a high-resolution ICU database. It is from my hospital, Beth Israel, and the goal of it is to try to produce an environment that is similar to what a physician would see when they stepped in the ICU. You would see all of their vitals, you would see their labs, you would see their progress notes, you would see the respiratory report notes, the ventilator settings. We have waveforms for a whole bunch of patients. So actually the arterial line waveforms, the electrodes, the EKGs, and soon in the next year or so, we're hoping to add in a whole bunch of chest x-rays as well. So we're trying to give as much information as we can to produce a longitudinal look at the patient's stay in the ICU, as well as what happens in terms of mortality after the ICU. And the mission of this is to try to encourage other people to do the same. And we have a collaboration with Philips, and they really liked what we did with Mimic, and they actually donated their own data to this repository. So they have 200,000 patients from ICUs from around the US from their systems that we now curate as well, which is so powerful in terms of the generalizability and the testing that you can do on it. And what's also nice is, in addition to just being an academic center, they have community hospitals and other ones as well. Along these lines, we've tried to encourage other centers as well to donate their data, because as you know, and it's been brought up multiple times, generalizability is a thing. Most of the studies that have been done are done on US populations, but there's a lot of people in the world. And so there's a lot of different practices and different things that go on in different treatments. So one of the things our lab does is we do data-thons around the world. And we hoped that by encouraging people to see how much power you can have by releasing this information and how much you can study in your population, they will as well. Like Zainbo and Peyao, who are here today, we had our third data-thon with them, or our third meeting with them this year, and they or amazing and able to use their own ICU data in this. There's a few other hospitals that are also trying to make their own little mimics, as you say. And when we go to New Zealand in January, they're trying to open up their data as well, so we'll use one of their data sets. So this statistic might be a little old, but there are about 3 presentations or publications involving Mimic a month. So that's just so much power. And regardless of the brilliance of one individual lab, it is no match for the brain power of people around the world and the amount of good that you can do from this data. But I'm probably preaching to the choir here in this particular room. Another thing that I think that is really important, and I'm going to share my experience, is the ability to sit in the lab and just sit next to my friends who are data scientists. And we're about 50% clinicians, 50% data scientists, and it really fosters collaboration and ideas. Like if my friends, Alistair and Tom, who are data scientists, have a question about the medical database, they'll just turn around and ask me about dialysis or ventilatory settings or lab values. And you can actually, it just makes the whole process so much smoother. And I think we have all benefited from this. Like they are very versed in medical terminology, and in turn, I learn a lot about data science and things as well. We have a course that we just wrapped up this year, HST 953, which is a course in collaborative data science. And this is a project course where we take data scientists and clinicians, and the data scientists are both students and people in industry or around Boston who are interested. We organize them into groups, and they spend the semester working on a particular project. And we've been moderating the groups. Leo's been doing a lot of work on this. But it's really great to watch the progression of the groups throughout the semester. They meet together, and you can hear the change in the way that they communicate with each other over time. And it's really rewarding to see how they grow to be able to communicate. And they just gave their presentations last week, and they were pretty phenomenal presentations. I do a lot of collaborative projects with people from Philips, and they're so excited about the data and creating tools that will be helpful. And one thing that I think has really helped them is when I go on wards and I attend in the hospital, I'll have a few Philips people come with me, and they will follow me on rounds, and they'll listen to my fellows and my residents present, and they will come to the dialysis unit with me, and we'll go through how the dialysis machine works and talk with the nurses and go to the ICUs and look at the monitors and look at the respirators. And they tell me afterwards, they're like, I had no idea what to expect. It's just so interesting. So for people that are collaborating, I would highly encourage you guys to go to the environment and see this, because I think it really clarifies a lot of things. Like when I tell them, sometimes it's not clear what someone's volume status is. It's when they come in the ICU and they see the patients, it makes it more clear why questions aren't always clear in the medical field. I think this conference is a place where this happens, this meeting of data scientists and clinicians. That's why it's so rewarding to be here. I feel like I can almost see new ideas like materialize above people's heads when they have conversations here, and I am so excited to be here, and I can't wait to see all of the things that you guys do. Thank you.
I'm a clinical pathologist and as well as a researcher in the Biomedical Informatics Research Division at Stanford University. And I'm here to tell you about the benefits of keeping an expert in the loop when you're deploying a technology that's using ML to basically provide generalized care decisions. It seems like this has obviously been discussed multiple times on this today and earlier, so I think nothing, oh, actually these are my old slides. Uh-oh. Oh no, okay. Guess don't, oh, there's no slides left then. So don't worry about that. And so my perspective on why you need to keep an expert in the loop is based on this last year. I have been the clinical lead of Informatics Console service at Stanford. And this service basically provides on-demand actionable insight generated from the electronic medical record to sort of inform patient care decisions. And we built this service to help solve for a challenge that faces physicians every day across the country. And that challenge is that how do you treat patients whose whose condition doesn't match the inclusion criteria that you find in published research. Work from a number of researchers has shown that in this type of situation, you can use practice-based evidence, which is evidence that's generated as a byproduct of routine patient care and entered into the EMR to guide therapy for these sorts of patients. However, the challenge remains, how do you quickly leverage the data that's in a large healthcare data set to provide such an analysis? And obviously, as everyone knows in this room, using ML and AI on large data sets to generate insight is, that has transformed a number of other industries, and it's only a matter of time before it comes to healthcare. So when our group was developing this sort of service, we had two main challenges to overcome. The first one was the standard technical challenge. How do we build a product that can quickly generate cohorts based on clinical definitions out of EMR data? How can we set that up for downstream statistical analysis, do all that analysis, and then provide reassurance that the data set was robust enough to answer the question that we did answer, and have controls that lets us give assurance that the answer is something that we can trust. Although this is quite difficult, the whizzes in the lab of Nikam Shah at Stanford University were able to rise to the challenge and create all that technology. The second challenge we faced is, though, how would a service like this actually interact within the routine clinical care? What sort of aspects would clinicians expect to see for them to garner trust in this sort of system? How can we be so sure that we're even on the same page as the clinician when we're answering a question? And a lot of these decisions boil down to, or a lot of the aspects of this challenge boil down to product design issues. And it turns out that they're just as hard, if not harder to solve than the technical ML background. And so what we decided, and why is this? Well, clinicians are quite difficult to work with. For everyone here that's worked with, you already know that they're extremely skeptical. Buzzwords AI and ML don't really mean anything to them. They're also very well aware, as we saw in the last panel, about the limitations of the data collected in large healthcare data sets. They realize they're incomplete, and they need to be convinced that any insights generated from those are actually meet the bar of evidence that they are accustomed to. Finally, they're really busy. They don't have 30 minutes to interact with a system to detail their question in some web form. They want to have just a normal clinical interaction that they have and get back to managing the dozen patients that they're taking care of. Because of this, we modeled our service after a system that clinicians are already well versed in when they want to seek advice to guide therapy for patients. And that's a clinical consult. For those of you not involved with direct clinical care, a clinical consult is where one physician requests advice from another clinician who has domain expertise to guide the therapy of a patient. So if I was a pediatrician taking care of a patient, I want to start a medication that might be damaging to the kidney, and this patient has lupus, I would consult a nephrologist to determine, should I do this or should I not do this? And when you have a consult, you have two physicians that are speaking together. They have a common clinical language between them and a shared clinical experience. And thus, they are able to discuss a problem as they're confronted with it in the care setting. In our product, the Informatics consult, which there would be a diagram if this slide was working, we have a requesting provider interacting with an informatics clinician. And this informatics clinician basically has an intake discussion with a requesting provider to understand truly what is it that they're trying to extract from the EMR that's going to help them generate insight into how to treat a patient. Then the informatics trained physician goes to an EMR data specialist and a data scientist also working in the group, and they sort of design the cohort and do all the robustness and analysis to determine, is the data set actually applicable or usable to answer this sort of question? And what are the limitations in the data and the analysis? And then if those can be adjusted for, great. If not, that's described and propagated in a report to the requesting physician. And then that requesting physician has the informatics physician that they can discuss with and say, hey, I don't understand this. Can you explain me how this works? What are these limitations? And can you answer these follow-up questions? And so by keeping the model facing two clinicians, we can both increase the trust in the system as well as increase its usability in the healthcare setting. And we think this sort of consult model is actually a way that many new AI technologies could be brought into the real-world patient care setting. Thank you.
Okay. Very interesting. And I think that okay, I'm going to get right to my questions because I have a lot. So first, starting with Layla, EQ in technology. This is a new concept for me. It's frankly a little provocative. So I'm a computer scientist. And, we are a branch of mathematics, and as a computer scientist in my training, and then also as a professor, we teach about logic and ration and objectivity and, mathematics. These are the first order principles of designing a good program. It's true that recently there have been some people interested in sort of human-computer interaction. That was a novel idea to me about 10 years ago. But EQ, almost sounds like you're talking about artificial empathy, designing systems that are things that we are willing to work with and trust. So first of all, why? Why is it the case that you think EQ is so important to designing these systems? Because to me, that's kind of a provocative statement.
So I think that even though our intention is for increased AI immersion in our society, that it's still a new concept for your brain. And so we're in these immersive platforms, but to your brain, it's still artificial. And so though we're trying to design it as, oh, this is just like a human, and oh, this is just like how it would be in the real world, it's still artificial, so your brain hasn't had enough evolution for it to engage in it in the same way that it does in the human space, which is why adding EQ components enables you to actually have more human familiar elements that increase human engagement.
So kind of goes to the trust issue that Saurabh was talking about. How do we as humans build systems that other people are going to trust?
On a deep neural level, right?
Right, interesting. So it's not just about being right, it's about being, it's about other things than just showing effectiveness or objective accuracy is not sufficient.
Because you can design the most phenomenal systems, but at the end of the day, you're designing them for a population that if they're not engaging with it, you've lost the opportunity for all of that impact.
Can I cut in a little bit?
Yeah.
So I think this holds true for physicians as well. You can have these brilliant physicians with completely the right, perfect treatment, but if you don't have the patients engaged, they don't necessarily trust or follow the advice.
Right.
So I can only imagine what your meetings with your clients are like. I've been working in Silicon Valley and San Francisco tech scene for a while now, and I can imagine that when you walk into a technology company and you tell them that they ought to think about how that makes their customers feel and emotions, that you're met with a wide variety of reactions. So how has this idea of injecting emotionality into technology been received?
So ironically, there's an abundance of research that, we talked about a couple of them, that talks about how much of your decision making is subconscious and is emotion based. And every scientist, every non-scientist, every person will shake their head and agree and say, oh yeah, I understand the science. And then it fails in translation when you say, okay, you understand the science, now let's actually talk about applying it. The upside is that I am seeing it, that sort of shift to be more part of the conversation, but in my opinion, nowhere near where it needs to be.
It sounds like you're saying there has to be more conversation to be done to understand what are algorithms and computers good at and what are they not good at, and use that to inject humans into the process in a more meaningful way, which is a segue to what Saurabh was discussing in his really fascinating work that you're doing with bringing the consult model or the expert in the loop model into machine learning. And I'm curious, as this is an increasingly popular paradigm, this sort of expert in the loop paradigm. I've seen it in many different domains, not just medicine, but it's an increasingly common paradigm. And I think at first blush, my assumption was that this is sort of a stopgap measure. Like, right? Like, the only reason we need to bring the human into the conversation is because our models are not yet perfect. But that ultimately, the vision is that we will develop artificial intelligence systems that are as good, if not better, than a human, and won't require any human at all. That's maybe a far way off into the future. But is this? It sounds like you're saying that that's not the future, but that this expert in the loop paradigm is in and of itself probably the best trade-off between man and machine.
Yeah, so I like to say, so I think in the long-term future, yes, there will be a day where a machine alone eclipses what man plus machine can do. But we're definitely in the situation now that we were in earlier projects for AI, where man plus machine is still significantly better than machine alone or man alone. So if you look at things like chess back in the day, or Go, you'd have a situation where a decent chess player with a computer could actually beat someone like Bobby Fischer. And now you're in a situation where a computer can always win no matter what. In healthcare, we're definitely in that situation. And a lot of that is limited to the fact that the data sets that we're going to use to generate insights are just inherently incomplete. Even if you have something as beautiful and perfect as a mimic data set for what is the data that clinicians see while they're in the hospital, that still doesn't capture actually everything that is being taken into account by the physician on the clinical care team. And so unless you could reinvent sort of the hospital setting where all the data that could be captured is captured, you'll be left to a system where you do need some human interpretation on machine learning models in order to have the best overall outcome.
Right, and for the result to be something that people buy into and trust, right? Which kind of dovetails with Layla's point.
Yeah, actually, I think what Layla's doing is really fascinating, because we found that right in the beginning when we started our service that physicians actually didn't trust our system that much. And then we tried to build trust by adding a number of positive and negative controls, as you would in any sort of research publication. And that did increase the trust a little bit, but it never got to the point where they trusted it fully and they were willing to say, I'm gonna always go with this decision as opposed to the decision that we've been doing in the past, even though they fully know that the decision they were doing in the past wasn't based on evidence, which is why they did the consults in the first place.
Right, and it's a different way of thinking about problem solving. And it sounds like what you've done is had to teach a new process, and in order to establish a comfort level there for the physicians to do this consult. But if other institutions wanted to roll out something similar, this consult model, what are the challenges in doing that? What are the sort of the roadblocks organizationally or process-wise or people-wise?
Yeah, so the roadblocks have actually been evident since the 1970s. People have been trying to do this exactly what we're doing since 1970. And back then, the challenges were threefold. A, there was no well-curated medical health data. There was a lack of algorithms, and there was a lack of personnel to actually that could talk both the medical talk and the data science to deliver the final product. Now, I think the data sets are coming along. We have things like Mimic. We have all the EMR data at your own institution. The personnel requirements, there's a number of people with advanced data science backgrounds that can do much of the actual data science parts. We still have a lack of physicians that can talk to data science, but I think that's growing. There's a informatics fellowship and things like that. And then the biggest challenge now is sort of buy-in from the institution. To get something like this off the ground, to build a clinical service that's going to be this sort of informatics consult, you need to get buy-in from your CEO, because most likely it's going to be a loss of money in the beginning. Your CIO, because they have to sign off on all the data use agreements for the data being used to inform patient care for a patient that it was not originally collected for. You also need to get buy-in from your medical risk groups. So right now, institutional buy-in is definitely the biggest barrier to developing one of these sort of systems at your own home institution.
Right, that makes a lot of sense. I mean, I see that in industry as well. In order to affect a broad, almost cultural change, it has to start at the top. within an organization, and having that buy-in from the top level, and frankly, vision, is really a requirement to getting it off the ground. Okay, so Christina, hello. First of all, what is a datathon? Can you just define that? Because that's not necessarily a household word.
Wonderful. So I'd love to. So basically, it's been mentioned before, but I think they're wonderful, so I'm gonna mention it again. So a datathon is where we have a data set and then we have people pitch ideas, like clinical ideas in our datathons, that they wanna have solved. And we get together groups of data scientists and clinicians, and they work together to figure out how to structure the problem, what data is needed, and how they're going to answer this in a very short period, like a day or 2 days. I actually met my lab in a datathon. I had hurt my foot and I couldn't go climbing in the mountains, and I went to this datathon, and it was amazing. I had so much fun, and you get really swept into the idea and you get really excited, and I stayed up all night programming, and it was really great. And then I joined the lab.
Okay. So that's a little plug to have you look out for your own local datathon opportunities. Okay, the work that you're doing, especially with this MIMIC data set, is really powerful. I can't believe that you're having such an impact. I mean, I can believe, but it's really a testament to say that there are 3 publications a month that are leveraging this data set that you're providing out of the goodness of your heart. And, what we're seeing with the advent of machine learning is this renewed emphasis on data. It's not just about digitization of data, but it's really changing the way we think about data as having value. And there's one of the tenets of machine learning is that more data begets better models. And so, you can't have a conversation about machine learning without data. But I'm curious because I've heard 2 very contradictory descriptions of data. In industry, a lot of industries, we talk about data as an asset, as a business asset that is proprietary, and a lever for competitive advantage should be protected and guarded. But here, I've heard people referring to data as a commodity that ought to be liberated. Everyone's liberating data. So which is it? Why is medicine different?
Well, I think that's a great question, and different people have different opinions, and I think perhaps a lot of us in this room are of the opinion that someone's health is something that's just, I think, a right. Like, people have a right to have healthcare. People have a right to, have people treat them. And I think that all this data that we have and all the places that we've collected can really help change the way that we take care of patients and change the way that this happens. And I don't think that's something that you can really put a price tag on, right? This is something that might help change the way I do chronic kidney disease or determine blood pressure targets. And in my opinion, it's a public commodity, and it's a public health commodity. And I think that the benefit to society and governments making it open is phenomenal.
And academic institutions,
Yes.
right? And hospitals, sounds like.
I agree with everything you said. I think another issue why data needs to be a commodity in healthcare is that no single institution has enough breadth and width of the data to actually recapitulate the complexities of clinical care across the country. And so actually having a commodity where we're transferring data between institutions is going to just be required to drive the insights that we want to drive.
And also, we go to a lot of other countries, and treatments in Australia and New Zealand versus China or France or Brazil, they're very different. And the people that they have in the different countries are very different. The care may be also different. And so to make it generalizable just to people in general, I think it's important to have the insights of more places.
That's really interesting. I mean, I think that in some ways that makes medicine a little unique compared to industry, where people build walled gardens of proprietary data sets that they collect. And it perhaps indicates that some of the machine learning results that we'll see coming out of medicine will be stronger or more powerful than in other industries because of this tendency towards sharing of data, this sort of collaborative effort. Well, thank you to my panelists. I'd like to open up the floor to questions from the audience at this time.
So who owns data? It's always a question in these things. But have you heard about Page in New York City, the pathology company, where they got exclusive rights to use the pathology archive at Sloan Kettering? So what do you think about that? So it's a public good, but they are using it for the greater good, but also making money. So should it be just made available? Do they need to go back to the pathologists who did those reports and pay them? Do they have to get permission from the patients from 50 years ago?
So I could give my opinion on it. And as I said before, I think that regardless of how brilliant one group is and how much technology they have, it's no match for people around the world. Like people are just so smart. There's so many smart people out there. And I think that would be more powerful if you open it up to everyone. Also, what we also encourage is reproducibility and opening up the code that you get and how you were able to do it. And when you have these closed systems, sometimes it's difficult to see what they're doing, to build upon it, to figure it out, and to trust what's going on in the background as well.
My perspective on that particular situation is that's a real situation where you do need industry buy-in, because to produce scan images from glass slides, for people that don't know, a single glass slide scanned at 40x is something like 10 gigs of data. And we're talking about millions and millions of glass slides. It's an absolutely unfathomable amount of data, much more than like all of Facebook would have for all of their cases. You could imagine a system that would be more beneficial where you sign an exclusive limited time agreement where a company like Page would maybe get 5 years of exclusivity because they're creating the infrastructure to scan all these slides, host all these slides on some sort of cloud, and do all that. And they can derive whatever insights they can, generate any IP over 5-10 years. But after that, those sorts of data sets should be public. I think that would make a great industry academia partnership.
Great, we've got another question at the front here.
The question is about the clinical informatics consult. It's actually it's an interesting new concept. So in my mind, it opens a pathway from the evidence-based medicine towards the clinical intelligence-based medicine. When you keep the human in the loop, like the expert in the loop, does it work out the other way as well, as the feedback provided by the experts on how well they are satisfied with it and whether they are going to adopt it? Does it help you to tweak the quality of future consults? And do you have any data about, let's say if you did 100 consults, what was the traction amongst them and adoption amongst them?
Yes, thank you very much. 100%. So this is the first sort of its service in the country, so we're considering it in a pilot phase. And we do a debrief on every single clinician that uses the service, and we try to learn what can we basically use from their feedback that we can make the service better. The whole concept of adding positive and negative controls so you can ascertain, is this answer make sense in the realm of all the other questions we could ask for the same cohort? That's been really powerful and something we glean by talking to experts. As far as the summary of the first 100 consults, we're having a publication that will be produced in the next couple months that will sort of describe what the feedback was and what the traction was amongst users.
One more question to your right.
Good afternoon. Question for Layla, specifically around EQ versus just what's called user experience design, because there's a lot of talk of designing information systems so that the user has a positive experience. Is EQ just a subset of that, or do you view it as different?
Great question. So in my mind, the difference between the two is we can use the same word, let's say feeling, And for user experience, that has a more technical meaning, as opposed to feeling in psychology and human behavior means something very different. And so the difference between those two when you're talking about EQ is one is much more emotional, human language, et cetera, as opposed to in UX, they look at it, in my mind, more from a structural, technical standpoint. And so I think that's where we're missing, is that looking at it from more the psychology standpoint, it is much more about the human language of sensation.
Can I add to that? I would say it's a combination of that, where when you're looking at the UX, I think it's having both people involved, where the UX
Absolutely.
takes into account designing for trust, designing for action, designing for feeling. And you definitely need, the understanding of the psychology of that and the collaboration between everybody.
Absolutely.
To do
So
that.
it's not a replacement for UX.
Yeah.
It's a complement to UX, so that the UX is done in a way that speaks the language
Yeah.
of human engagement, so that it's designed better to increase that engagement.
Yeah. Questions from anyone?
Fantastic talks. One of the key components of human interaction, decision making in medicine, is the ability to make mistakes, and also to have sort of a fuzzy logic. It's not just neuronal systems, it's like a fuzzy quantum computing type of thinking on multiple different levels and taking different things into account and coming up with the answer, rather than a linear one of connecting what is the correct answer, I'm going for that answer. And how do you, and when do you see that those will be integrated, and where do you see the role of that, for example, for the clinical consult? Where do you see the role of that for humanizing technology so that it's much more usable? And
The role for allowing for mistakes.
allowing for mistakes, or actually making mistakes part of the positive portion of this, because you're much more willing to make mistakes looking for a positive answer. In other words, you seek out other possibilities. It's that creativity part, rather than an algorithm that is used typically in the past for AI.
I can answer that from the consult service. I think you're totally correct. You would want to move in an eventual direction where you can have some sort of hypothesis-free interaction with the system, where you don't have to say, tell me the difference between medication and medication B on heart rate at 3 months. That might be something you're already thinking about, but if the system could do something that says actually between medication A, B through D, and also not looking at only the outcomes you're saying you're interested, but learn from other publications or what's happening to patients, a number of different outcomes, that would be a fantastic way to go. I think what we're doing is a baby step in that direction, but I totally agree. We would want to take some of the more intuitive, hypothesis-free approaches that people have when they come up with research projects and sort of embed that into our AI decisions.
And I think from an EQ perspective, that's exactly one of the benefits of humans do make mistakes, and they aren't these they don't have this linear predictability, and so designing in a way that is more about human engagement takes into account a lot of that. A simple example of that would be in context. So and we did in the workshop yesterday, one of the examples we used is an image of a fire. So image of a fire to someone in California in the last 6 months means something very different than, like we had a workshop member that was from Japan. Image of fire doesn't do the same sort of trigger in him. And so what are the ways in which in your design, in your technology, you're accounting for context, error, the way humans work sort of in their natural landscape?
So I'll just add a comment and speak on behalf of the robots. That in fact, deep learning is not linear. The models are not at all linear. And that's actually, I think, the central innovation there, is that there really are, and that's why they're difficult to explain or to comprehend sometimes, because they're so complex, these models. And oftentimes, especially when we're using something like supervised learning in a medical context, there is no objective ground truth. There's merely the stated gold standard that has been provided by some human expert. So to the extent that we are building models to replicate human behavior, as long as humans are fallible, the models will also be. If you ask two different physicians for opinion on a patient, you might get two very different answers. And so sometimes there's no objective truth, and these models are meant to mimic that behavior.
But that's very different than quantum computing, where you have multiple states that can be positive at the same time rather than zeros and one. One is correct or not correct. I think human thinking in some ways is much more quantum computing than current zeros and ones. And I'm wondering what you think about that.
So, well, I'm happy to talk at length about quantum computing at some point, but I think you might be conflating probabilities with decision making. So in medicine, at the end of a consult, the physician makes the decision, takes an action, prescribes a medication or a treatment. And so even if they are unsure that there might be an alternative explanation or an alternative treatment that might work better, that at the end of the day they have to make a decision. So there's still that element to it.
I have actually a couple of questions. One of them is for EQ, because I'm a clinical psychologist, specialized in psycho-oncology, but one of them is about when you lose the human contact and interaction. My clinical observation and some evidence-based research shows the suicidal ideation and depression rises. Where is the boundary on this artificial intelligence entering into as a support system in medicine? And how do we prevent that kind of a clinical symptomatic level? And the second things I usually read and connect in several other artificial intelligence related some people that there are questions about what if artificial intelligence takes over human life and they destroy us. How can we prevent it that? Those are the two ones that I'm interested in hearing.
Layla?
So we're going to save the world. It's a great question. So with reference to the first question, I think that if I had to pick between no care and at least artificial intelligence care, I would pick artificial intelligence care because at least you're getting something. There's so many applications where in the younger populations, they won't turn to a person, but they'll turn to chatbots and virtual platforms. In refugee populations, access to care is limited, but through AI technology, providing mental health to them, they're engaging with it in that way. So if I had to pick between zero and AI, 100% I would pick AI. However, I do think that, and we talked about this yesterday in the workshop, that if the immersion is coming anyway, one of the things that'll happen is we as human beings will have feelings for the technology because it's just the way we are. There's a phenomenal TED Talk about, there was a robot and people were, they did the study and they tried to have people break the robot and people couldn't do it and they had feelings about it and it was really difficult for them. So we will have feelings for the robot, especially as the robot is continuing to get designed to be more engaging with us. How's your day? How are you feeling? I see you're sad today. We're gonna have feelings for it anyway, and so if that's gonna happen, we're better served designing it to be more human engaging anyway, so that at least it can offer some amount of reciprocation. And to your second question about, is it gonna take over the world? I don't think so, because I'd like to still be here, but also because I think there's, no matter how much it can do, no matter how much technology and AI and VR and all these things are so phenomenal, it's a human that's still driving that. And I think it's to Saurabh's point about the man plus machine still wins over man or machine.
I'm afraid we're going to have to stop it there. Thank you very much to our panel.